Moving on with the next sections of the review, doing matrix determinants and inverses. The determinants, I expect you to do these by hand. Now you can use a calculator to check your answer, but I am expecting this to be done by hand. Remember, determinants, you do downhill minus uphill. If it's a 2 by 2, it's really easy because you will simply take this downhill right here, 2 times negative 4. I believe 2 times negative 4. I'm just going to write it as 2 times negative 4. Is that okay? And then you subtract, and then you multiply going uphill. So let's go uphill. And that will be minus negative 3 times 5. And then we simply work that out. 2 times negative 4 is negative 8, minus, that'd be a negative 15, which is negative 8 plus 15, and that's the determinant of 7. If you want to do this in the calculator, you would store this as matrix A, and then in the calculator you would find the DET command, whether it's an 84 or an 89, and you'll do determinant of matrix A, and that's only to check your answer. I want you to be able to do this by hand. Number 8, if it's a 3 by 3, we have two ways of doing this. Probably the most straightforward way is to simply recopy the first two columns. So I'm going to copy down 1, negative 2, and 2, and then 0, 4, and 7. And then we will multiply going downhill. It's still downhill minus uphill, except now we just have a lot more downhills to do. Whoa, that was bad. So I'd multiply those going down, and when I multiply those, I get, we add those products also. So 1 times 4 times 0 plus 0 times 5 times 2, this is sexy, plus 3 times negative 2 is negative 6 times 7 is negative 42. And then we will subtract, and then we will add the products of the uphills. So now I will do those three, and these three. Okay, so going up, 2 times 4 times 3 is 24, plus 7 times 5 times 1 is 35, plus 0 times negative 2 times 0, and then we work this out. So that'd be negative 42 minus 24 and 35 is 59. Negative 42 minus 59 would be negative 101. And there's your determinant for number 8. I do want to show y'all another way to do this one, just in case some of y'all want to do the second technique for number 8. And that technique is called expansion by minors. If y'all remember, this is the one where you always keep the first row hidden, and then we start by covering up the first column. Oh, I meant that to be a fat one. Let's go back. There. And then we will cover the first column. And since I'm covering up the 1, this 1 is being covered in both the row and the column. So times 1, I will do the determinant of this little small 2 by 2 matrix. So 4 times 0 minus 5 times 7. Then we'll do minus, and then in parentheses, I'm going to do another one, but now I'm going to cover up the second row. And now I'm covering up 0, and then I'll do negative 2 times 0 minus 2 times 5, and then plus, I'll cover up my third column, and now the 3 is at the top of the third column, so I'm going to multiply this by 3, and then I'll do the determinant of this matrix, negative 2 times 7, and 2 times 4 minus 8, which is 2 times 4, and then we clean this up. 0 minus 35 times 1 minus, now this is nice because it's negative 10 times 0, which is going to go away, plus that's negative 22 times 3. This is 0, so that's going to go away. And we have negative 35 plus a negative 66, which ends up being negative 101. The same thing we got with the other technique. That's called expansion by minors. I don't care which way you do it. I do want you to show the work and do this by hand. You are free to check it on the calculator, but you need to have all of this work shown, whether you do expansion by minors like I just did, or if you do the downhill minus uphill here. But you have to show the work showing me that you can do this by hand. Use the calculator to check your answer. So let's see, number 9, we're finding the inverses of these. Now, inverses, if it's a 2 by 2, and that's what this star means, I want you to do this by hand. And the formula for the inverse is you do 1 over the determinant. So I'm going to do downhill minus the uphill times, and then we swap the position of the 2 going downhill. So instead of 1, -8, it's going to be -8 and 1. And then we change the signs of the other 2. So instead of +3 and +2, it's -3 and -2. -8 minus 6 is -14. So that's 1 over -14 times -8, -3, -2, 1. And then I will multiply that -1/14 through everything. So that's going to be, let's see, a negative times a negative, that's going to be +8 over 14. And then -3 times 1 over -14 will be +3 over 14. The negatives cancel. And then again, the negatives cancel with the -2, so that'd be 2 over 14. And -1/14 times 1 is -1/14. And then finally, I will reduce those fractions. So 8 over 14 reduces to 4 over 7. 3 over 14 doesn't reduce. 2 over 14 is 1 over 7. And -1 over 14 is already simplified. And there's our answer for number 9. And again, I want to see the work. You need to show me that you can do this by hand because the calculator can do inverses, and I'm actually expecting you to use the calculator on number 10. So number 10, I'm going to store this matrix for A. And then to do the determinant in the calculator, you simply do A and you raise it to the -1 power. Now in the calculator syntax, that's going to be written as A rooftop, and then in parentheses, I like to put -1. If it's a TI-89 or a TI-84, there is a -1 exponent button that you will hit. But either way, you'll punch that in, and the answer you'll get for this one is an inverse of, and they're usually really ugly. The 89s will default to a fraction, and the fractions are hideous: 12 over 31, -17 over 62, and I'll tell you what, I'm going to pause this while I'm writing this. You don't need to watch me write it. There we go. So there's our answer. Again, the 89s should default to giving you the fraction answers. If you're on a TI-84 or an 83, then what you'll want to do to get the fractions is you will hit the math button, and then you will select frac. So do math frac, and that will convert the decimals into fractions for you, so you can get something a little bit sexier than some crazy repeated never-ending decimals. And that's it for this part.